Hello everyone, welcome to my Your Programming Club. Today we'll be solving daily Leetcode challenge, and the challenge's name is put marbles in bags. According to the problem statement, you have been given k bags and you are given a zero indexed array called weights, where each element in the array is the weight of the ith marble. You have been also given an integer k. You are required to divide the marbles into k bags according to the following rules. No bag should be empty, means you cannot place 0 marbles inside a bag. If you decide to put ith marble and the jth marble in a bag, then all the marbles with indices between ith and jth indices should be in the same bag. What the problem statement is saying is, for an example, let's take the first sample input as our example. Let's mark the indices 0, 1, 2, 3. K is given as 2. What the problem is saying that if you decide to put this marble, say at ith index, and this marble at jth index, then you have to put all the marbles in between these two indices also. So you have to put, if you decide to put 1 and 5, you should put 3 also in the bag, same bag. Okay, till now we are clear. Then what are the rules saying? If a bag consists of the marbles with indices from I to j inclusively, then the cost of the bag is weight of the ith marble or the ith index marble and weight of the jth marble. Okay, so let's move back to our example. So here we decided to put the 0th index and the second index one in the bag, which is 1 and 5. So the cost of the bag would be 1 plus 5 is equal to 6. Okay, then the problem is saying that the score after distributing the marbles is the sum of the total cost of k bags. Okay, so the overall score would be the sum of k bags, cost of sum of cost of k bags, cost of bag 1 plus cost of bag k. Okay, this is what the problem statement is saying till now, and we are asked to return the difference between the maximum and the minimum scores among marble distributions. So we have to find out the maximum score possible and the minimum score possible by placing marbles into k bags and return their difference as the answer. Okay, now we would be making our first observation. Let me clear the screen. Yeah, now first observation. If we are to put some marbles in a bag, then we can rightfully say that we have to divide the array into parts. For an example, here k was 2, so we are required to put all the marbles in the array into two separate bags, two bags. For two bags we would be requiring to divide the array into two, you can say, partitions or two parts. So we have to place a partition somewhere to divide the array into two halves. So if we can place the partition here, 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 anywhere you may like, and it can be observed that here two bags were required, so single partition would divide the array into two parts. So if in general you are required to put the marbles into k bags, then for k bags k minus 1 partitions are required. Okay, and then where to place these partitions? You have to place these partitions in between these array, in between these indices. So for an array of size n, you would be having n minus 1 spaces where you can place the partition. You can place the partition here, here, or here. So these will be the options to place the partitions. Okay, now we will be coming to our second observation. For that, let me clear the board. Second observation. Second observation will be, if you decide to put a partition here, then what this partition will be doing is, to the overall score we want to obtain, which is as of now 0, this partition will be adding this value and this value to the score. So the score would be 3 plus 5, and these first index and the last index will always be included, whatever partitions you are going to make, because you are going to make partition only in these available spaces. So these indices will also always be included, so you do not have to worry about that. So our main goal is to maximize the score and minimize the score and return the difference of the maximum possible and minimum possible scores. Okay, now further extending our observation, we can place partition at n minus 1 spaces if the size of the array is n. So what we would be doing is simply just uh, for a single partition, value that partition will be adding to overall score is, let's say we put the partition after the ith index, then the value that partition will be, let's say this partition is p1, the value this partition will be adding to the overall score is weight of ith index plus weight of I plus 1th index. It would be adding 1 plus 3 is equal to 4 to the overall score. So this is the final observation, and based on that what we will be forming a array for n minus 1 partitions and adding values of these partitions. So let's say P1 partition adds value V1, P2 partition adds value V2 to the score, P3 partition adds value V3 to the score, and so on. And then we will be sorting the array. So we will be sorting the array to get the partitions who are contributing maximum to the score and minimum to the score. And in this way, let me take another slide. In this way we would be able to find maximum score possible and minimum score possible. Now you may ask how we would be finding the minimum score and the maximum score. Let me clear the board first. If we have to pick k minus 1 partitions for k backs to get max score, we would be picking the partitions which is contributing maximum value to score. So if we sort the contributions of partitions in ascending order, we would be picking k minus 1 values from the end to get the maximum score, and same way we would be picking k minus 1 values that that partitions will be adding from the beginning for the minimum score, and we would be simply returning the difference. Now let's look at the code. Just a second, let me zoom out. Yeah. So the code is would be available in both of the languages, C++ and Java, and I will be putting it in a GitHub repository, and you don't have to worry about copying the code or something like that. So what we have done is we have initialized the answer variable, then we have here simply written the length of the weights array, and then this is the length of the partition array that I have been talking about, this partition array, which would be containing values. Each partition, ith partition, will be contributing the overall score. So this is the length of the partition array, and this is the index to iterate over the partition array. Then we are simply declaring a partition array of that much length, n minus 1 length, and here is w length. Okay, then we have declared it. Then we would be putting values for each individual partition in the partition array. Then we have initialized the index to iterate to put values in the partition array, and the value of a particular partition would be nothing but the sum of the index after which the partition is put and the sum of the next index. Okay, then we would be sorting the partition array as I told in the explanation part. Then after sorting the partition array, we would be simply taking k minus 1 values from the end and k minus 1 values for the beginning for the max part sum and minimum part sum, which I have done here. Then we would be simply returning the max part sum and minimum part sum. Okay, let's submit the problem once. So as you can see, the problem is submitted and we got our result. So thank you very much for watching. Stay tuned with the channel for daily Leetcode challenges, and as our subscriber base will be growing, we will be adding more platforms to the more coding platforms in general to the channel, like Code Chef, Code Forces, etc. Thanks.